previous video, we created basic visualizations using ggplot2. In this lesson, we'll enhance those plots by applying professional themes, customizing colors, and using faceting to compare subgroups. These techniques will help you create clear, publication quality figures for public health reports and research. We start by creating a base plot and saving it as an object called P. Instead of printing the plot immediately, we assign it to P. This is useful because it allows us to reuse and modify the same plot without rewriting all the code. Here we create a histogram of BMI with labels for the title and axes. Once we type P, the plot is displayed. Saving plots like this makes your workflow cleaner and more efficient, especially when experimenting with different styles. Next, we apply different themes. Themes control the overall appearance of a plot. ggplot2 provides several built-in themes that improve readability and presentation. Theme underscore minimal creates a clean, modern look with minimal background elements. Theme underscore BW creates a black and white theme that's often useful for publications. In public health research, choosing a clean theme improves readability and ensures your visuals are suitable for reports, presentations, or academic papers. Colors help highlight group differences and improve interpretability. However, colors should be used carefully to maintain clarity and accessibility. Let's add color to a box plot of BMI by sex. By adding fill equals sex inside AES, we tell ggplot to color each box according to the sex category. This improves visual distinction between groups. Then we use scale underscore fill underscore manual to manually choose specific colors, in this case, steel blue and orange. Manual color control is helpful when preparing figures for publication, ensuring accessibility, or when we are trying to keep consistent branding in presentations. Clear group differentiation is especially important when comparing health outcomes across populations. Faceting allows us to create multiple panels based on a grouping variable. This is especially useful for comparing distributions across subpopulations. When we use facet underscore wrapsex, ggplot creates separate histograms of BMI for each sex. This makes it easier to compare distributions side by side. Instead of overlapping groups in one plot, faceting gives each group its own panel. This is particularly useful in public health when exploring disparities across demographic or behavioral categories. We also facet by smoking status. This allows us to visually assess whether BMI distributions differ between smokers and non-smokers, a useful exploratory step before formal statistical testing. Faceting helps reveal patterns that may not be visible in a single combined plot. Finally, we improve readability in a bar chart of smoking status. We rotate the x-axis labels slightly using element underscore text angle equals 30 so they don't overlap. We also make the plot title larger and bold for emphasis. Small adjustments like these make a big difference in clarity. In public health communication, readability matters because stakeholders, including policymakers and community partners, rely on clear visuals to interpret findings correctly. You now have the core skills needed to create professional visualizations in R. In the next section of the series, we'll begin statistical analysis, starting with basic inferential methods used in public health research.